Hello everyone, I am Dharmendra Kumar Chaudhary. In continuation, in this video, we will study about the evaluation of the Dyestuff. This video is a continuation, part 2 of this topic. In this video, starting before this video, we will just summarize what was studied in the last video of the same topic. In the last video, we had discussed about the evaluations of Dyestuff, on which parameter is required, that is a strength, U, and other characteristics of the with respect to the particular class of dye, and different methods for the evaluations of the Dyestuff, that is chemical method, colorimetric method, or by actual dyeing trials in a laboratory. And we also discussed about the limitations and advantage of these three different methods, and then we will discuss about the chemical methods of evaluation of Dyestuff purity for direct dyes, acid dye based on azo class and the naphthol and its base, and then purity of wet dye, indigo salt, etc. In this video, we will discuss about the how to estimate the purity of the reactive Dyestuff. For purity of the reactive Dyestuff estimation, a known amount of a Dyestuff is completely hydrolyzed with caustic soda by refluxing it for 6 hours. So the complete hydrolysis of reactive dye is carried out, and then the alkali consumption is determined by potentiometric methods, that is titration, and the purity of the Dyestuff is estimated on the basis of the alkali consumptions. So for what amount, for complete hydrolysis, what amount of alkali, that is caustic soda, is required, is measured, and this is the base for reactive Dyestuff purity. As the consumption of alkali is higher, then we can say that as the higher consumption of alkali indicated the more percentage purity, so the amount of dye present in this molecule will be high. So as the alkali consumption increases, purity of the Dyestuff is considered more. So like in this fashion, we had discussed all quantitative estimations of all type of the dyes. Now we will discuss about some other methods, that is colorimetric methods, our laboratory dyeing trials methods. Now first we will discuss about the colorimetric methods. As you know, suggest colorimetric methods. In this colorimetric methods, we measure the optical density of a solution, our absorbance of a solution by using a spectrophotometer or colorimeters. As you all know, we can estimate or we can find out the concentration of a unknown solutions by measuring its absorbance, by concentration of color in unknown solution by measuring its absorbance, because each color gives its absorbance at lambda maximum. So at lambda maximum wavelength, we measure the max absorbance of this of any solution, and then compare the absorbance. This absorbance is the calibration curve. So now just we discussed in a very simple way about the how to calculate the amount of any type of color of Dyestuff in any solution via spectrophotometric method, that is colorimetric method. In this way, in this method, for unknown any Dyestuff, we prepare a solution of a known concentration. We prepare a solution of a known concentration at different known concentration, like say 0.1 gram per liter, or 0.1 gram per liter, 0.2 gram per liter, 0.5 gram. Like in the increasing order, we prepare the solutions of any Dyestuff of known concentration, and after preparing these different concentration solution of the same dye stuff, we measure the absorbance of each solutions. After measuring absorbance of the each solution, we plot the graph. On y-axis we put absorbance, on x-axis we put concentrations. So by putting absorbance of respective concentration, we make a graph, and this is known as calibration curve. This calibration curve is look like that. If here we prepare a calibration curve, this is y-axis, this is x-axis, this is absorbance, and this is concentration. Here we put concentration 1, concentration 2, concentration 3, concentration 4, 5 in this fashion like that, and here is absorbance 1, 2, 3, 4, 5 like that. So we prepare graph like that. After a certain point, there is we hold the graph, we stop the increasing concentration, because for the dark solution there is no meaning to measuring the absorbance. For measurement of absorbance, solution should be light. So in this fashion we prepare a calibration curve. This is calibration curve. This is calibration curve. So once we prepared a calibration curve of an individual dye stuff, after that when we got a unknown concentration, a solution of the same dye stuff of unknown concentration, then we can measure the concentration of this unknown solution of the same dye stuff, because here the unknown solution, we take the unknown solution in a cuvette, put it in spectrophotometer for measurement of its absorbance at lambda maximum. So suppose that the absorbance of the unknown solution would come in this range. Suppose this is the assumption, this side, then we can plot the like that, the tangent is like that, so the concentration will be that. So we can measure the concentration. This concentration is between 2 to 3. If this graph is put on the proper graph paper, then we can know the exact concentration of this unknown solution. By this way we can measure the concentration of an unknown solution. If we measure the concentration of the unknown solution, then we can say that the amount of dye present in solution can be calculated. So in this way the quantitative estimation of the dye stuff can be determined. So in the next video we will discuss about the laboratory dyeing trial methods for the estimation of the dyes. Thank you.